Hi everyone. So there are four requirements for synchronization mechanism technique, and if any of the solution provided by, let's say, various other researchers have given this various other solutions, so these solutions will follow these four requirements which are given by the synchronization mechanism technique. So the primary requirement is, first, all the synchronization mechanism technique or the solution provided follow the mutual exclusion property. Mutual exclusion says at any time only one process can enter the critical section. So what is critical section? Critical section is the shared resource or shared memory which are shared between the two or more different processes. So what I'm trying to say, let's say you have write some code and your code requires the various shared resources, and your code as well as the other programmer's code requires the two shared resources which are same between these two shared codes. So these codes will be let's say this is the particular shared resource, okay, which are shared between the two different processes, okay. So this shared resource or this critical section, above this critical section we are using a particular code called as non-critical section, and below this critical section we are using some other codes called non-critical section. So critical before critical section some non-critical section code is present, and after some critical section code there is non-critical section code is also present, okay. And many processes trying to access this critical section or access this shared resources. So for protecting this shared resource from other processes and assure that only one process can enter this critical section and use this shared resource at a time, we are using mutual exclusion property. So mutual exclusion says at a time only one process can use this shared resource or use this critical section, okay. So it is at any time only one process can enter the critical section and use the shared resources. The next primary condition is progress. Progress means if, let's say, process P1 and P2 are running in the computer and they are trying to access the shared resource, this part. So if P1 is not interested to access the shared resource, then it will not stop the process P2 to access the shared resource. So if some other processes are not interested to access the critical section or shared resource, then they will not stop or force other them to stop using shared resources. So this is the second primary condition, progress. And these two are the main, and it will be it is compulsory, and you can say it is necessary condition for synchronization mechanism technique, okay. Apart from these two primary condition, the other conditions are also involved, which are secondary condition. So secondary condition is not necessary, but it is good if you are provide this if your solution provided these conditions as well. So the first secondary condition is bounded waiting. Bounded waiting means starvation problem. So starvation problem will not arise for some processes and for some other processes. For what I mean to say, let's say if more than two processes are running in the computer and process Pi or process Pj will wait for a longer time for this particular shared resource, then bounded waiting condition or bounded waiting requirement will ensure that this particular process or whatever be the process which are waiting longer will not wait, and it will get a fair chance to schedule to the to particular access this shared resource. So bounded waiting generally avoid starvation problem, okay. In short words, you can remember it as a bounded waiting can avoid starvation problem in synchronization mechanism technique, okay. And the secondary requirement is architectural neutrality or portability. What is architectural neutrality or portability? The solution you provide for synchronization mechanism will independent from the hardware, okay. It does not depend on the hardware. for what I mean to say, for example, you are providing a synchronization mechanism solution, and this synchronization mechanism solution require a specific hardware, then this is not a portability or not a architectural neutrality requirement. If your solution will run on Windows operating system as well as let's say Apple Mac OS operating system, then your solution will be hardware independent or called architectural neutrality, and it is also a sufficient condition. It is not necessary, but it is a secondary condition. Okay, so we have two primary conditions, one is mutual exclusion and progress, and two secondary conditions, one is bounded waiting and the other is architectural neutrality. Some solution provide the primary conditions, some solution will provide the primary condition as well as secondary condition both. So we will see all these solutions one by one in the upcoming videos. Okay, so in the next video we will see the first synchronization mechanism technique which are used in synchronization of processes.